In the last video, we saw that for symmetric distributions, we can summarize the data by stating the mean and the standard deviation. Most of the time, that's enough. There are a couple of other things, but those aren't, we usually don't worry too much about that on an everyday level. But what about with skewed distributions? As we saw, using the mean is heavily influenced by outliers, very large or very small values. And if there are a lot of very large or very small values, the mean can be a little bit misleading. The same goes with the standard deviation. So we need to use something else. What we're going to use comes from percentiles. So a percentile is the value in the data for which p% of the data is lower. So p is your percentile, the 50th percentile or the 70th percentile. So let's look at an example. So here's where we're going to get some data. We're back to Duolingo. And Duolingo gives you experience points, as we talked about in some examples in chapter 1. And over here on the right, you'll see something called the Diamond League. So what they do is they basically compare you to a random sample of 30 other folks who are using Duolingo, who are at a similar level to you. And you can move up leagues by finishing in the top 10 in a given league, and you can move up, and Diamond is the highest. So we see from the bottom, we can start to see some data. We've got 134 experience points, 178 experience points, 221 experience points, all the way up to 10,245 experience points. These are totals for the week so far. Up here it says 2 days are left. So in the week so far, this person has earned over 10,000 experience points. I wonder what else they do with their time. Where am I? Here's me. I'm down at number 10 with 1,525 for the week. So we're going to use this data. And to start, let's look at the bottom 16 in the Diamond League so far. So I've ordered them from smallest to largest. That makes it easy to find percentiles. And these are the 16 current lowest scores in my cohort, my randomly selected fellow Duolingo users in the Diamond League. So one common percentile that we use is a quartile, 25th, 35th, 25th percentile, quarter. That's the first quartile. So here that's 339. 25% of these scores are less than or equal to 339. That's the 25th percentile. The 50th percentile is 661. That's also called the second quartile, and we also know it as the median, which we know is where we measure center for a skewed distribution. The third quartile, the 75th percentile, is 1,041. Quartiles are not the only way we can split up a data set into percentiles. Quintiles, for example, 20%, 40%, 60%, 80%, 100%, those are common in income analysis. Let's take a look at United States income and the quintiles in 2018. This data comes from the Tax Policy Center. And we've got household income distributions from 1967 to 2018 broken up into quintiles. So let's look at right here in this region down in the lower right, the 2018 data. We see this is the upper limit. So the lowest quintile, which is the lowest 20th percent or the 20th percentile, are all values between 0 and 25,600. Those are the incomes. And the mean of all income earners in that range is 13,775 per year. The second quintile, the 40th percentile, is 50,000. And those whose income fall between 25,600 and 50,000 a year in 2018 average to 37,293, and so on. This is another example of percentiles, this time going by 20th percentiles, 1/5 of 100, quintiles. We can also, that's another way to break up data in terms of percentiles. Quartiles, however, have a special use in analyzing the spread of a skewed data set. Recall 339 is our first quartile, 25th percentile, 50th, 75th. Then the interquartile range, also called the IQR, is the difference between the 75th percentile, third quartile, and the 25th percentile, the first quartile. So in this example, that's 1041 minus 339, and that's 802 experience points. So these 16 Duolingo users, the interquartile range, the amount by which the data is spread, is 802 experience points. In the next video, we'll see how we summarize this information for a skewed distribution, and those summary statistics can also be used to describe a symmetric distribution as well. It's just not as common.